Hello guys, QED Math over here, and today we're going to be doing three more AIME geometry problems. Again, kind of on the easier side. With that being said, let's get into it and have fun. So a hexagon is inscribed in a circle and has side lengths 22, 22, 20, 22, 22, 20 in that order, and we want to find the radius of the circle. Okay, so what I'll do is roughly draw a circle. I guess maybe. Okay, roughly draw a circle, and then let's start with the points. So 22, maybe like that. 22, 20, 22. Okay, 22, 20. Not very drawn to scale, but I guess, or yeah. So I guess let's just label A, B, C, D, E, F. And then let's label what we have. So this will be 22, 22, 20, 22, 22. Yeah, it does not look like a 22, but yep. Okay, so we have these six side lengths. So we're gonna find the radius of the circle. So let's call the center point O. And then let's connect all these points, I guess, like this. Okay, so great. So now, of course, these will all be radiuses of the circle. So now let's consider some angles, I guess. So if we look at AOB, it's RR22. Let's call that angle alpha. And any side that has a 22 will be a congruent triangle, hence have the same angle. So this will be alpha. This will be alpha, and then this will be alpha. Okay, so we have four alphas, and then anything with the 20 will be the same angle. So if we call this one beta, then we have this one is also beta. So we have a relationship, I guess. If we sum all the angles, it's just a circle, so we get 360. So we have 4 alpha plus 2 beta is 360. So 2 alpha plus beta is equal to 180. All right, nice. So now I think the solution is kind of obvious. If we look at triangle AOB, for example, and apply the law of cosines, we'll get something in terms of like cosine alpha. And then if we apply a law of cosines on a triangle like AOF, we'll get something in terms of cosine beta. But then we can write cosine beta conveniently as cosine 180 minus 2 alpha, and then apply some double angle formula. And that way we can cancel cosine alphas and get something in terms of R, probably like a quadratic. So I guess let's do that. So again, recall triangle was like RR22 alpha. So 22 squared, 484 is equal to R squared plus R squared, which is 2R squared minus 2R squared cosine alpha. All right. And then the other triangle is like beta RR20. So again, 400 is equal to 2R squared minus 2R squared cosine beta. But remember from our relationship, this is true. So beta is 180 minus 2 alpha. So I guess cosine beta, which is equal to cosine 180 minus 2 alpha. And then 180 minus 2 alpha would be, well, cosine 180, cosine alpha, cosine 2 alpha. Yeah. Okay, so now we have, is it cosine 2 alpha? Yeah, it should be. Oh, wait, hold on, negative cosine 2 alpha. Again, I just used some angle. Probably a good thing to memorize though. So minus 2R squared, and then negative 2 cosine alpha, which is, I guess this can make this a plus, and then this will become like 2 cosine squared alpha minus 1. Alrighty, so now let's call this 1, let's call this 2, and then now let's do some simplification on the second equation. So 400 is equal to 2R squared, and then I guess this will become 4R squared cosine squared alpha, but then look, 2R squared will cancel with 2R squared, so we don't have to write that. Divide by 4, you get R squared cosine squared alpha is equal to 100, so R cosine alpha is 10, so cosine alpha is 10 by R. And then now that becomes easy, let's just plug this into equation 1. So 484 is equal to 2R squared minus 2R squared 10 over r, and then now it's just algebra. I guess, wait, what's that? That's negative 20 over r. So we have r squared minus 10r minus 242 is equal to 0. Okay, so now we just solve this quadratic. R is equal to 10 plus or minus the square root of 100 minus, what's 4 times 242? That's like 168, 968. Yeah, 968 divided by 2. Divided by 2. So 10 plus or minus, so root 1068, let's see, that should be divisible by 4. And then if you divide by 4, you get 250, 267. 267 looks prime. So it's not divisible by 2, divisible by 3, it is. So let's just see if when we divide by 3, it becomes a prime. 824, 2789 is prime. Okay, so we have 5 plus or minus root 267 is our answer. Certainly it's of this form. Minus becomes extraneous, so 5 plus 267 is 272. So our answer is 272. All right, let's move on to the next one. This is from the 1999 AIME, and it's problem 12. So the inscribed circle of ABC. So ABC, inscribed circle, same thing as the incircle, the intersection of the angle bisectors is tangent to AB at P, okay? So ABC, not the best drawings. Let me read that. All right, so somewhat better. Okay, so AB, C, intersection, tangent at P, radius 21. So O, maybe if I call this QR, we have 21 radius. Okay, so AP is 23. PB is 27. And find the perimeter of the triangle. Okay, great. So what I'll do is I'll call these radiuses R. And then now there's actually a simple way to do this. So if I call this whole thing A and I call this whole thing B, now let me just connect these guys. This radius is 21. Okay, so I actually may want to use that somewhere. So X R. Okay, so now here's what I'll do. Okay, so let me call this X. Or no, what am I saying? This has to be 23 because these are equal tangents, and this will have to be 27 because BQ is equal to BP by equal tangents. So then let me just call this guy X. All right, so now on one hand, I can find the area of the triangle using Heron's formula. And on the other hand, I can kind of find the area of the triangle by considering the three triangles, AOB, BOC, and AOC. So in a way, I can find the area by doing that kind of method, which I'll leave as an exercise to show is just R times S, where S is a semi-perimeter. So sum of the sides divided by 2. But then A by Heron's is also equal to RS minus A. I mean, is there an S? Yeah, it's an S, not an R. S minus A, S minus B, S minus C. I'll leave that as an exercise to prove as well. That's a nice trigonometric proof. Okay, hold on. S minus C. Okay. Anyways, S minus C. Okay, so now let's equate these two areas. So if I square both sides, I get R squared, S squared is equal to S minus A, S minus B, S minus C. Cancel the S. And I guess that's actually good information. So let's calculate S. S is going to be AB, which is 50, AC, which is 23 plus X, and then BC, which is 27 plus X, divided by 2, that's 100 plus 2X divided by 2, which is 50 plus X. So now let's just put our information. It said that the radius was 21, so 441 s is equal to s minus a. So a would be, I guess, 27 plus x. And I'm just using general convention where sides opposite side to an angle is basically the lower case of that. So this is a, this is b, this is c. So s minus a would then just be 23. So it's equal to 23. S minus b is equal to 50 plus x minus 23 minus x, which is 27, and then times x. And then let me put that as in 441, 50 plus x is equal to 23 times 27 times x. Okay, so what I can do now is I can do 441 times 50 is equal to, I'll use a nice trick here. This is 25 plus 2 times 25 minus 2, which is 25 squared minus 2 squared, which is 621. 621x minus 441x. So 441 times 50 is equal to 180. Yeah, 180x. All right, so now divide 441 times 50 over 180. Let's see what we get. Bam, bam. And then 441 is divisible by 9, so this becomes a 2. This would become 49. Yeah, 49. So 49 times 5 over 2. What was the question you asked for? It asked for the perimeter of the triangle. So I know that the perimeter would be 2 times the semi-perimeter, which is 100 plus 2x. So I have x in this form. So 100 plus 2 times this would be 100 times 49 plus 5, which is 345. All right, so last problem. This is from the 2003 AIME 2, and this was question 11. So triangle ABC is a right triangle with AC is 7 and then BC is 24. So let's do some drawing. This is good enough. And then like this, C, A, B, AC 7, BC is 24, right angle C, okay. M is the midpoint of AB. In other words, M is the circumcircle of triangle ABC. And D is on the same side of line AB, so that AD is equal to BD is equal to 15. So if I know that AD equals BD equals 15, I know that point D must lie on the perpendicular bisector of AB. So let me just call this point D. So AD is equal to BD is equal to 15. All right. Given that the area of CDM, okay, we want to find the area of CDM. So I guess we can do it like this. All right. So first, what do we know? We know that this is 7, this is 24. Pythagorean would give AB is equal to 25. So since M is the midpoint, so that means BM would be 25 over 2, AM would be 25 over 2. So I can easily find length MD if I wanted to by the Pythagorean theorem. Since again it's a perpendicular bisector. Also, what else can I do? I can easily find length CM. So CM is equal to AM equals MB because they're all circumradiuses of the triangle. You can see that by kind of like the perpendicular of BC. Yes, anyway, CM is equal to 25 over 2. So we can find that. So if I have CM and MD, if I can find this angle, it'll be really easy to find the area of triangle CDM. So how can I do that? Well, it's easy. I have a 90, I have this angle. So if I consider 90 plus that angle, and I have the 3 side lengths, CM is 25 over 2, CMB is 25 over 2, and CB is 24. So I can probably find cosine alpha and then consequently sine alpha, and then I can use 1/2 CMMD sine alpha to find the answer. So let's just put that as a diagram and then law of cosines, I guess. So what? Oh, okay, I went back. So CMB, okay, CMB, 90 plus alpha. Let's see, CM 25 or 2, 25 or 2, 24. So cosine 90 plus alpha would be 25 over 2 squared plus 25 over 2 squared minus 24 squared over 2, 25 over 2, 25 over 2. Okay, so let's calculate this. So 25 over 2 squared is 625 over 4. If you add that 2 times, you get 625 over 2. And then minus 24 squared is 576 over 2 times 25 over 2 times 25 over 2. So we get 25 times 25 over 2, which is 625 over 2. So this is essentially equal to 1 minus 1152 over 625, which is equal to 625 minus 1152 is 535, negative 527 over 625. Okay. So what's cosine alpha now? What's cosine 90 plus alpha now? That's cosine 90 cosine alpha minus sine 90 sine alpha. So that's negative sine alpha. Perfect. So we have negative sine alpha is equal to negative this. So sine alpha therefore is 527 over 625. All right. So now let's use that formula. So CMD. So CMD, we need to find MD. Let me do that in this page. MD is equal to root BD squared, which is 15 squared, minus MD squared, which is 25 over 2 squared. This is equal to root 225 minus 625 over 4, which is 900 minus 625 is 275. So root 275 over 4. So that's 5 root 11 over 2. Okay, so we found this. So let's go. We have 1/2. So 5 root 11 over 2 is what we calculated as MD. CM is 25 over 2 because it's a circumradius. And then sine alpha. What was sine alpha? Sine alpha is 527 over 625. All right, so nice stuff happens. 525 will go 5. So 527 root 11 over 40. Is that simplified enough? 4 does not go in, 5 does not go in, 2, and okay. So yeah, this is our answer. So we want to find m plus n plus p. Okay, we have it in the correct form. So that'd be 567 plus 11, which is 578. All right, hope you guys enjoyed watching this video. Again, 3 fairly straightforward problems. I'll go into the harder ones soon. Leave a like, please subscribe, and thank you for watching.